Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning exercise 1.4 from the chapter sets. Okay, even this is a very easy exercise. This exercise deals with union of sets, intersection of sets, complementation of a given set and difference of the two given sets. Okay, so already I have given you the introduction in the introduction part. If you have not watched that video, I will attach the link in the description box. Please do watch it. Okay, now let's move on to the questions. Find the union of each of the following pairs of sets. Okay, so in this question they are asking us to find the union. Union means x union y. This is the symbol for union, isn't it? So here, what is union of sets? We have to have all the elements in set x and y, and the common elements should be taken only once, isn't it? So 1, 3, 5 as it is, and next here 2. That's it. Okay, so this is the union of x and y. Okay, so now subdivision to a is equal to a e I o u and b is equal to a b c. So now to find a union b is equal to a e I o u. You just write all the elements from set A. Okay, then you check in set B. If common elements are there, just leave it. Then you go to the next one. Okay, so now A, B and C is not here. So now I'm writing B and C. Next one, third subdivision. A is equal to x such that x is a natural number and multiple of 3. It means that 3, 6, 9, 12, 15, etc. It goes on. This is the set A. Okay, so next set B is equal to x such that x is a natural number less than 6. It means B is equal to 1, 2, 3, 4 and 5. 6 is not present here. Why? Because it is less than 6. Okay, the natural number is less than 6, so we are not taking 6. So what will be A union B is equal to x such that x is equal to 1, 2, don't write 3 because 3 is a multiple of 3, isn't it? So 4, 5 or multiple of 3. Since it is union, we have to take two sets also. No, the common terms should be taken only once. So only I am not taking 3 here. Instead, I am writing it as multiple of 3 or a multiple of 3. Division 4, A is equal to x such that x is a natural number and 1 less than x less than or equal to 6. B is equal to x such that x is a natural number and 6 less than x less than 10. So now we will write it in the roster form. So A is equal to, since it is an open closed interval, 1 will not be included. So 2, 3, 4, 5 and 6, since here it is closed. Okay, so B is equal to 7. Since this is open interval, it is 7, 8 and 9. Now A union B is equal to 2. I'm writing this set A as it is 3, 4, 5, 6. Now let me check whether any common elements are present in A as well as B. No elements, no. So therefore I will write 7, 8 and 9. Fifth subdivision, A is equal to 1, 2, 3. B is equal to 5. I've already taught you A union 5 is equal to A only, isn't it? So using that, we will be writing A union B is equal to 1, 2, 3. Question 2. Let A is equal to A comma B. B is equal to A comma B comma C. Is A subset of B? What is A union B? So now this is the first part of the question. Till here it is first part. And this is the second part. Now we have to check, is A subset of B? Okay, next one what we have to check is that what is A union B? So now let's move on to the solution. So since every element in set A is present in set B also, I am saying that A is subset of B. You can write yes, A is subset of B. So the second part, what are they asking? What is A union B? No. So A union B is equal to, so I'm writing all the elements from set A as it is, A comma B. And now let me move on to set B. A is present, already written, B also. So only C is left over. So therefore C. So what is this set over here? B, no. So therefore I will write A union B is equal to B. Set B. Question 3. If A and B are two sets such that A is subset of B, then what is A union B? So in the previous question, we already said that since A is subdivision of B, then A union B is equal to B only, no? So it means that if A is subset of B, it means all the elements present in A is present even in B. So what if we take A union B? Only the elements in set B will be present, isn't it? So therefore A union B. If A is subset of B, then A union B is equal to set B. Question 4. If A is equal to 1, 2, 3, 4 and B is equal to 3, 4, 5, 6, C is equal to 5, 6, 7, 8 and D is equal to 7, 8, 9, 10, find first subdivision A union B. We already saw a question, no? A union B, the same thing we have to write. So here first let me write all the elements that is present in A. Okay, so now 1, 2, 3 and 4. So now let me move on to set B. Already we have 3 and 4 in set A, no? So leaving out that, we will write the remaining 5 and 6. Why I am taking like this? Because the common elements should be taken only once, no? So only I am taking like this. Next subdivision, A union C. So now for this also the same thing. I will write all the elements that is present in A. 1, 2, 3, 4. Then I will move on to C. Okay. So now I don't have any common elements. So I have to write all. So 5, 6, 7 and 8. Next, third subdivision is B union C. So now I have to write all the elements from set B or set C. You can write set C and then also B. But to not to confuse, I'm just writing set B first. 3, 4, 5, 6. Next I'll move on to here. So here I have 5 and 6 common, no? So only 7 and 8 will be taken. That's it. So subdivision 4, B union D is equal to, first I will write all the elements from set B, that is 3, 4, 5, 6. Then from set D. So set D, it starts from 7 only, no? So I will write 7, 8, 9 and 10. So fifth subdivision will be A union B union C. Okay, now let me just group it, okay, so that it will be easy for me. So A union B I have already found, no? So A union B contains 1, 2, 3, 4, 5, 6, no? Then after that I will find A union C. What is A? First I will group. First let me write what is A union B. 1, 2, 3, 4, 5 and 6 union. What is C here? C is 5, 6, 7 and 8. No, so I will write the union for this. First, let me write first set A. 1, 2, 3, 4, 5 and 6 union. No, so I have to leave out the common elements. So this is common, this is also common. So therefore 7 and 8. Subdivision 6. A union B union D. So already we have found B union D also. Now even this you can group it. Whatever is easy for you all, you can take. Let me take A union B itself. 1, 2, 3, 4, 5, 6. Union. What is D? 7, 8, 9 and 10. So what will be union for this? 1, 2, 3, 4, 5, 6 and no elements is common, so therefore 7, 8, 9 and 10. Okay, so now seventh subdivision is B union C union D. So already we have found B union C, no? So let me write this set 3, 4, 5, 6, 7, 8. Union D. What is D's set is 7, 8, 9 and 10. Okay, so now I have to find the union. So let me write this set first. So 3, 4, 5, 6, 7, 8. So now I have to leave out the common elements. This is common, this is also common. So 9 and 10. Question 5. Find the intersection of the following pairs. So in the previous question we were learning about union, no? So in this question we will be finding only the intersection. What is intersection? Finding the common elements in the given 2 or 3 sets. So first subdivision, x is equal to 1, 3, 5, y is equal to 1, 2, 3. So now x intersection y, this is the intersection symbol, no? So therefore x intersection y is equal to, what are common over here? 1 is here as well as here. So I will write 1. Next 3. So 3 is here, 3 is also here. So therefore the elements are over. 5 is here, 5 is not here, no? So we can just leave it. So 1 and 3 is common for both x and y. That is the intersection, okay? Now next subdivision, A is equal to A, E, I, O, U. B is equal to A, B, C. So now my A intersection B is equal to, what are common here? A is here, A is here also. So I will write A. So E is here, E is not here, no? I, no I, O, nothing. So U, nothing. So just like that I can leave. A is the only common element. Subdivision 3, A is equal to x such that x is a natural number and multiple of 3. It means like A is equal to 3, 6, 9, 12, 15, etc. It keeps on going. Okay. So next subdivision B is equal to x such that x is a natural number less than 6. Natural number starts from 1, 2, 3, etc. No, since it is less than alone, I will write only till 5. 1, 2, 3, 4 and 5. So what will be my A intersection B? Only the common elements, no? So here, what is common? 3 is here, 3 is here, okay? So 6 is not there because 6 is greater, no? So just like that, I can finish it off. So A intersection B is equal to 3. Fourth subdivision, A is equal to X such that X is a natural number and 1 less than X less than or equal to 6. It means A is equal to, since it is open closed interval, I will write 2, 3, 4, 5, 6. Next, B is equal to X such that X is a natural number and 6 less than X less than 10. This is open interval. So I will not include 6, so 7, 8 and 9. So now what will be my A intersection B? Only the common elements, no? So therefore, what is common here? Nothing. So I can just leave it as empty, or A intersection B is equal to null set. Any one you can write. A is equal to 1, 2, 3. B is equal to 5. Already we have learnt a formula. A intersection 5 is equal to 5. Now using that we will be writing A intersection B is equal to 5. Since no elements is common, here it is empty set. No, there's no element over here. Then what is common? Nothing. So that also will be empty set. So only I'm writing it as 5. Question 6. If A is equal to 3, 5, 7, 9, 11, B is equal to 7, 9, 11, 13, C is equal to 11, 13, 15, and D is equal to 15, 17, find A intersection B. So, I will write A intersection B is equal to 3, 5, 7, 9, 11 intersection, what is it set? 7, 9, 11, 13. Okay, now here what all is common we have to check. Okay, that is what intersection. No, 3 is here, not here. 5, no 5. So 7 is here and here. So I will write 7, then 9, 9, then 11 and 11. So that's it. My set here is over. So I will stop with this. 7, 9, 11 is the common elements. Second subdivision, B intersection C is equal to, where what is B? 7, 9, 11, 13. Intersection, what is C? 11, 13, 15. So what will be my answer here? 11 and 13. Since only those two elements are common, I will write 11 and 13. So A intersection C intersection D is equal to 3, 5, 7, 9, 11 intersection 11, 13, 15 intersection 15, 17. So now what are common for all the three? We'll see, or else we'll just group it. Okay, so you can directly do it if you're used to it. If not, if this is confusing for you, then you can group any two. Any two, okay? However you do, you get the same answer. So here, let me see first. So here only 11 is common. So I will write 11. Any other? No. So intersection 15, 17. Is there anything that is common for both these sets? No. So therefore, A intersection C intersection D is equal to 5. Empty. Subdivision 4, A intersection C. So A intersection C is equal to 3, 5, 7, 9, 11 intersection 11, 13, 15. So here what is common? 11 is common here. So anything else? No. So therefore we will stop with this. Subdivision 5, B intersection D. So B intersection D is equal to, what is set B? 7, 9, 11, 13. Intersection D is 15, 17. So what is common here? Nothing. So therefore I will write 5 as the answer. Next subdivision, A intersection B union C they have given. So A intersection B union C within brackets is equal to, my set A is 3, 5, 7, 9, 11. Intersection, I'll use the square brackets. Then 7, 9, 11, 13. Union 11, 13, 15. So next I will have 3, 5, 7, 9, 11. Intersection, what it is union, no? So we have to write 7, 9, 11, 13. And here 11 and 13 are common, so I'm just leaving. Then 15, since it is union. Next one, we have to check what all is common, no? So here 3, no, 3, 5, no. 7 is here. So 7, then 9, then 11. So only these 3 elements are common. So therefore, this is my intersection. Seventh subdivision, A intersection D. So A intersection D is equal to, what is my A? 3, 5, 7, 9, 11. Intersection D is equal to 15, 17. So what all is common here? We have to check. Okay. So what is common? Nothing. So therefore it is 5. Subdivision 8, A intersection B union C. Okay, so now first we have to find B union D. So 7, 9, 11, 13, union 15, 17. So I will write this as it is: 7, 9, 11, 13, 15 and 17. Since I don't have any common element, I can just write like that. So A intersection B union D is equal to 3, 5, 7, 9, 11. Intersection 7, 9, 11, 13, 15, 17. So therefore, what all is common? Here 7, 9 and 11. No. So therefore 7, 9, 11. Next subdivision, A intersection B. So we already found what is A intersection B. No. A intersection B union C. 7, 9, 11. If you check the previous answer, you will know. Intersection B union C also we have found. What is that? 7, 9, 11, 13, 15. So now intersection of these two sets. So 7, 7, 7, 9, 9, then 11, 11. So therefore, over. Next subdivision, A union D intersection B union C. So A union D only we have to find. So A union D is equal to, what is my A? 3, 5, 7, 9, 11. Union D is 15, 17. So therefore my set will be 3, 5, 7, 9, 11, 15, 17. And I already know that B union C is equal to 7, 9, 11, 13, 15. So I have to find these intersection, isn't it? So A union D intersection B union C is equal to 3, 5, 7, 9, 11, 15, 17. Intersection 7, 11, 13, 15. So what is this intersection? 3, 7, 9, 11 and 15. So 7, 9, 11, 15 is the answer. Question 7. If A is equal to x such that x is a natural number, B is equal to x such that x is an even natural number, C is equal to x such that x is an odd natural number, and D is equal to x such that x is a prime number. So now let us write the given sets in roster form for better understanding. So here it is natural number, no? So 1, 2, 3, etc. Set B will be even natural number, no? So 2, 4, 6, comma, etc. C is equal to odd natural number, so therefore it will be 1, 3, 5, etc. And D will be prime number, no? So 2, 3, 5, etc. First subdivision, A intersection B. So now we have to find A intersection B is equal to, what is the set A? 1, 2, 3. No, just write it in roster form. Intersection 2, 4, 6, etc. So therefore, what is intersection now? Even natural numbers contains all the numbers. Here even numbers contains only 2, 4, 6, 8, etc. No, only even numbers. What is intersection then? Only the even numbers, okay? Because every numbers will be natural numbers, but here only even numbers will be there. Even number is present even in set A. So therefore the intersection will be set of even numbers only. So since the question is given in set builder form, we have to write it in set builder form only. Why I wrote like this? Because for your understanding only. So therefore we will write x such that x is an even natural number. Is that clear? If you have any doubts, just mention it in the comment box so that I will make you more and more clear with one more video. Next one, A intersection. See what is a A? 1, 2, 3, etc. Even if you want to do with direct set builder form also you can do if you're more and more clear. So what is set C? 1, 3, 5, etc. Isn't it? So here every numbers are there. Okay, here only odd numbers are there. So this, I will say that this is a subset of this set. Okay, so what will be the intersection automatically? Only this set. Why? Because only 1, 2, 3, the odd numbers will be common, because every numbers are present here and only odd numbers are present over here. Then what will be the common element? Only odd numbers. No, so therefore x such that x is an odd natural number. Natural number. Is that clear? Next question, A intersection D. So what is our A? 1, 2, 3, etc. Intersection prime numbers 2, 5, 2, 3, 5, etc. So here natural number contains all the elements, whereas the set D contains only the prime numbers from this set. Okay, so what will be the intersection of both these sets? Only this set, which is a prime number. So therefore I will write x such that x is a prime number. Subdivision 4, B intersection C. Okay, so now let's write B is equal to, what is our B? It's an even numbers, isn't it? So 1, 2, 4, 6, 8, etc. Now, so what is a C? C is equal to 1, 3, 5, etc. So now they have asked what is B intersection C. So B contains all the set of even numbers. C contains set of all odd numbers. Is there any common element? No, isn't it? So therefore B intersection C is equal to 5. Null set. Okay, so next one, fifth subdivision, B intersection D. Here B intersection D is equal to, what is B? It is set of all even numbers. No, so 6 comma etc intersection prime number. So 2, 3, 5, etc. So now here it is set of all even numbers. Okay, be clear and watch it fully without skipping. 2, 3, 5, these are prime numbers. Okay, so now in prime numbers, only 2 is even, isn't it? Any other prime number, any other even number you take, everything will be composite only. Okay, in prime numbers, only 2 is even. Okay, so therefore, I will say that B intersection D is equal to 2. Okay, any other even number you take, this will be composite except 2. Okay, therefore, 2 is the answer. Subdivision 6, C intersection D. So C intersection D is equal to set of all prime numbers and odd numbers. No, 3, 5, etc. So now here it will be 3, 5 and etc. Why? Because in odd numbers there are many. Why? Because in odd numbers only 1, 2, 3, because in odd numbers 1, 3, 5, 7, etc. it will be there, and in prime numbers 2, 3, 5, and also the prime numbers will have only odd numbers maximum. Only 2 is even number here, isn't it? So any other odd number will be taken, but we don't know what is that odd number, so only we are just writing 3, 5. 7 also you can write because we know no 7 etc. Question 8. Which of the following pairs of set are disjoint? I already taught you what is disjoint in the introduction part. No, if you have not watched that video, please do watch it. I will attach the link in the description box. So disjoint set means which does not have any common elements. That is A intersection B is equal to 5. Then it is called disjoint set. Okay. So here the two sets are given. So 1, 2, 3, 4 is given. So let this set be A. Let just write, let A is equal to 1, 2, 3, 4, and let this be set B is equal to x such that x is a natural number and 4 less than equal to x less than equal to 6. Since this is a closed interval, the start and end point will be included. So 4, 5 and 6. Okay, so now for disjoint set we have to get A intersection B is equal to 5. Okay, so here A intersection B is equal to, what is common over here? 4. No, so therefore which is not equal to 5, therefore it is not a disjoint set. Question 2. Two sets are given here also. So A, E, I, O, U and C, D, E, F. Okay. So here let set A is equal to A, E, I, O, U and set B, C, D, E and F. So A intersection B is equal to, what is common over here? E, only E, no? So E. So which is not a null set. Therefore, it is not a disjoint set. Third subdivision, x such that x is an even number, x such that x is an odd number. So here it will be let set A is equal to 2, 4, 6, 8, etc. B is equal to what? 1, 3, 5, 7, etc. So is there any common elements? Never. So therefore A intersection B is equal to 5. Therefore it is a disjoint set. Question 9. If A is equal to 3, 6, 9, 12, 15, 18, 21, B is equal to 4, 8, 12, 16, 20, C is equal to 2, 4, 6, 8, 10, 12, 14, 16, D is equal to 5, 10, 15, 20, then we have to find the difference of the given two sets. Okay. So now I already taught you what is difference. So A is equal to 3, 6, 9, 12. Next B is equal to what? 4, 8, 12, 16, 20. So A minus B or A difference B is equal to the set of all elements in A except the common elements. Okay, so if for example 3 is over here, 3 is not here, 6 is here, 6 is not here, 9 is here, 9 is not here, but 12 is here, but 12 is also here. So then I have to cancel this element, then I have to write the remaining element. So 3, 6 and 9, this is my answer. Second subdivision, so A is equal to 3, 6, 9, 12 and C is equal to 2, 4, 6, 8, 12, 10, 12, 14 and 16. So A difference C is equal to set of all elements in A except the common elements. So 3 is here, 3 not here, 6 is here, 6 is here, 9 no. So 12, 12. So what is the remaining? 3, 9. I have to write all the elements from set A, but the elements which are common I should not write. A difference B. A difference D. So A is equal to 3, 6, 9, 12 and D is equal to 5, 10, 15, 20. So what is A difference D? Set of all elements in A except the common elements in set A and D. So here 3, no 3, 6, no 6, 9, no 9. 12 nothing, so therefore I will have 3, 6, 9, 12 as the answer. So here B is equal to 4, 8, 12, 16, 20 and A is equal to 3, 6, 9, 12, 15, 18, 21. So B difference A is equal to set of all elements in set B except the common elements in both A and B. So 4 is here. Is 4 here? No. So 8. No 8. 12. Yes, 12 is here. So I have to cancel. Next 16. No 16. So 20. No 20. So this is my answer. Now C difference, yes, C is equal to 2, 4, 6, 8, 10, 12, 14 and 16. A is equal to 3, 6, 9, 12, 15, 18 and 21. So C difference A is equal to set of all elements in C except the elements in set A. So 2 here, not here, 6 here, so 6 here as well as here. So 8, no 10, 10, no 10, 12 is here, that's it. So 2, 4, 8, 10, 14 and 16. This is my answer. Subdivision 6, D difference A. What is D? D is equal to 5, 10, 15 and 20. A is equal to 3, 6, 9, 12, 15, 18 and 21. So D difference A is equal to set of all elements in set D except the elements in set A. So is there anything? Yes, 15. Okay. So 5, 10, 20. B difference C. What is set B? 4, 8, 12, 16, 20. And C is equal to 2, 4, 6, 8, 10, 12, 14 and 16. So B difference C is equal to 4, 4, 8, 8, 12, 12, 16, 16. So 20. So now B is equal to B difference D, no? So B is equal to 4, 8, 12, 16, 20. And D is equal to 5, 10, 15 and 20. So B difference D is equal to 20, 20 cancel. So therefore 4, 8, 12 and 16. So C is equal to 2, 4, 6, 8, 10, 12, 14 and 16. So then B is equal to 4, 8, 12, 16 and 20. So C difference B is equal to set of all elements in set B, set C except the elements which is common for both C and B. So 2, 4, 8, 12 and 16. So therefore 6, 10 and 14. 2 also. 2, 6, 10, 14. So next D difference B. So D is equal to 5, 10, 15, 20. Then B is equal to 4, 8, 12, 16 and 20. So D difference B is equal to set of all elements in set D except the elements in set B. So 20, 20 cancel. So 5, 10 and 15. Next, C difference D. So set C is equal to 2, 4, 6, 8, 10, 12, 14 and 16. Then D is equal to 5, 10, 15, 20. So 10, 10 cancel, 20, not 20. So C difference D is equal to 2, 4, 6, 8, 12, 14 and 16. 12th subdivision D difference C. So D is equal to 5, 10, 15 and 20. C is equal to 2, 4, 6, 8, 10, 12, 14 and 16. D difference C is equal to 10, 10 cancel. So therefore 5, 15 and 20. Question 10. If x is equal to a, b, c, d and y is equal to f, b, d, g, find x difference y. So what is our x? A, b, c, d. Then y is equal to f, b, d, g. So x difference y is equal to b and b cancel, d and d cancel. So therefore a, c. Next subdivision, y is equal to f, b, d, g. Then x is equal to a, b, c, d. So y difference x is equal to b, b cancel, d, d cancel. So f, g. Next, x intersection y. So x intersection y is equal to A comma B comma C comma D intersection F comma B comma D comma G. So what is common over here? B, B, D, D. So B comma D is the answer. Next question, if R is the set of real numbers and Q is the set of rational numbers, then what is R difference Q? They have given that R means real numbers. Okay. Next, Q means rational numbers. Fine. So, real numbers means rational plus irrational. Fine. Now they are asking R minus Q. It means like R is equal to rational plus irrational. No. So, real minus, if I take this side, rational is equal to irrational. No. So, therefore, this is my answer. So real numbers minus rational numbers means it is irrational number. No. So therefore our difference Q is equal to set of all irrational numbers. Irrational numbers. Question 12. State whether each of the following statement is true or false. Justify your answer. So now this is just a true or false. So first subdivision, 2, 3, 4, 5 and 3, 6 are disjoint sets. Is this disjoint set? No. Why? Because they have common element which is 3. So they are joint sets. So therefore this statement is false. Then subdivision 2, A, E, I, O, U and A, B, C, D are disjoint sets. Is it? No, because A is common over here. So therefore they are not disjoint set. Then they are false. So justification, you can say that A intersection B, let this be A and let this be B, then set A and set B intersection is A. So therefore which is not equal to 5. So therefore the statement is wrong. Next question, 2, 6, 10, 14 and 3, 7, 11, 15 are disjoint sets. Of course, why? Because let this be set A, set B. Set A intersection set B is equal to 5. So, which is correct. So, therefore, this is true. Next question, 2, 6, 10 and 3, 7, 11 are disjoint sets. Yes, why? Because A intersection B will be 5, which is a null set. So, therefore, it is disjoint sets. This exercise is over. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.